February 19th, 1945. No 900 hours. The landing beaches of Iwo Jima erupted into chaos as the first assault waves of the United States Marines touched volcanic sand still smoking from 3 days of naval bombardment. The island, a barren piece of rock 8 square miles in size, lay 800 miles south of Tokyo. Intelligence reports had called it formidable. The reality exceeded every assessment. Within the first 4 hours, 2,420 Marines were killed or wounded. The beach itself became a killing field of black volcanic ash, churned by artillery fire. Sherman tanks bogged down in terrain that looked solid from 500 yards away, but functioned like quicksand once vehicles committed their weight. Officers found themselves commanding platoons reduced to squad strength. Riflemen discovered that conventional cover offered no protection against Japanese gunfire originating from positions they could not see. General Tadamichi Kuribayashi, appointed to command Iwo Jima's defense in June 1944, had spent 8 months transforming the island into something unprecedented in Pacific warfare. Kuribayashi had studied the failures at Saipan, Peleliu, and the Philippines. The traditional Japanese defensive doctrine, meeting the enemy at the water's edge, launching massive banzai charges against American firepower, had proven catastrophically ineffective. The general had made a revolutionary decision that violated centuries of samurai tradition. There would be no glorious charges, no warriors seeking honorable death in open combat. Instead, 21,000 men would fight from underground, turning Iwo Jima into a subterranean killing field. By February 1945, Japanese engineers had completed 11 miles of interconnected tunnels, with plans for 17 miles total. The completed tunnel network reached 7 stories deep into the volcanic rock. 5,000 caves and underground chambers had been carved out, many large enough to hold 300 to 400 soldiers. 1,500 fortified positions dotted the landscape, concrete bunkers with walls 4 feet thick, reinforced with steel rods salvaged from abandoned construction projects, crowned every strategic height. Each position was carefully sited to provide interlocking fields of fire. Every inch of the island's surface could be swept by Japanese guns, hidden behind steel doors that opened only to fire, then sealed shut against retaliation. The tunnel system itself represented engineering on a scale the Americans had not anticipated. Ventilation shafts disguised as natural rock formations provided fresh air throughout the network. Underground hospitals with operating theaters were equipped to handle 400 wounded. Communications centers buried 75 feet below ground coordinated defensive operations through miles of telephone wire. Storage chambers held enough rice, water, and ammunition to sustain the garrison for 2 months. The largest, underground structure, positioned beneath Hill 382, contained a chamber 50 meters long and 20 meters wide, large enough to shelter an entire battalion. Kuribayashi had positioned his forces with mathematical precision. The southern sector around Mount Suribachi was designated a semi-independent command under Colonel Kanehiko Atsuchi, with 2,000 men manning artillery positions that could fire on the landing beaches. The northern plateau, where the terrain was most favorable for defense, held the bulk of Japanese forces. 15,000 men under direct control of Kuribayashi himself. Between these strongholds, a central reserve of 4,000 troops could reinforce any threatened sector through the tunnel network. The general understood with crystalline clarity that he could not defeat the Americans. His mission was fundamentally different. Make the capture of Iwo Jima so costly that the United States would reconsider invading the Japanese homeland. American planners had known the island would be difficult. Intelligence reports suggested well-prepared defenses. But the full scope of Kuribayashi's underground fortress remained hidden from aerial reconnaissance. 74 consecutive days of bombing had dropped 6,800 tons of explosives on the island. Naval bombardment had hurled 22,000 shells onto Japanese positions. American commanders expected these preparations to have eliminated most resistance. They projected the island would fall in 5 days. They were catastrophically wrong. The preliminary bombardment had destroyed fewer than 200 of the 1,500 fortified positions. The tunnel system remained virtually intact. Most Japanese soldiers had not been scratched by the massive firepower demonstration. On February 20th, the second day of the invasion, the mathematics of American conventional warfare were failing. Naval gunfire could not penetrate bunkers buried under 10 feet of volcanic rock and concrete. Artillery shells exploded harmlessly against positions designed to withstand direct hits from 16-inch naval guns. Marine riflemen found themselves attacking fortifications that might as well have been solid mountains. The advance had stalled at less than 700 yards from the beaches, far short of objectives that called for capturing the first airfield within the first day. Across the Pacific at Schofield Barracks, Hawaii, 5 months earlier, a different kind of war had begun. Colonel George Unmarked, a career Army officer with 44 years of military service, had been tasked with an impossible mission. He commanded the United States Army Chemical Warfare Service's most secret project in the Central Pacific area. His mission was explicit and unambiguous. Develop a weapon system capable of neutralizing Japanese cave and bunker complexes that had proven immune to conventional weapons. Unmarked understood the magnitude of his task required exceptional talent. The ABA initial team was small, just the 43rd Chemical Laboratory Company. But Unmarked requisitioned 25 men from the 117th Naval Construction Battalion, the Seabees whose mechanical genius and practical engineering skills were legendary throughout the Pacific. He added personnel from the 5th Marine Tank Battalion and the 81st Ordnance Company, creating a unique joint service team united by a single purpose: build a weapon that could neutralize fortified positions that artillery could not destroy. The technical challenge was daunting. Previous attempts to mount flamethrowers on tanks had produced mixed results. The Army's initial designs were crude field modifications, essentially portable flamethrowers bolted onto tank hulls. The Canadian Ronson system, which the Marines had acquired 30 units of, had a range limited to 60 to 80 yards with thickened fuel. Fuel capacity allowed only 30 to 40 seconds of total fire. The weapons were maintenance nightmares that frequently malfunctioned in combat with failure rates exceeding 40% in field conditions. The concept was theoretically sound. The execution was practically useless. The first breakthrough came with M3 light tank conversions, dubbed Satan tanks. The 43rd Chemical Company's first creation, a vehicle nicknamed Hells of Fire, had demonstrated the concept's potential, but revealed critical limitations. The turret traverse was limited to 180 degrees. The flame gun's elevation was restricted. Most critically, the light tank's thin armor made it vulnerable to Japanese 47mm anti-tank guns that were standard equipment in defensive positions. The Army needed something better: an armored platform that could approach fortified positions under cover of its own armor while delivering accurate incendiary attacks at unprecedented range. Through military channels that reached to the highest levels, Unmarked reported directly to Admiral Chester Nimitz's staff. The search for suitable vehicles produced a solution. 8 M4A3 Sherman medium tanks were located, available for conversion. These tanks displaced 35 tons, powered by a 500-horsepower Ford GAA V8 engine with armor ranging from 25mm to 76mm thickness. Standard armament included a 75mm main gun and multiple 30-caliber machine guns. The Shermans had proven their durability in European combat and possessed the armor protection necessary to survive Japanese anti-tank fire. Finding tanks was only the beginning. The real innovation came when the technical team decided to combine the best elements from 3 existing flamethrower systems: the British Ronson, the Navy Mark I, and captured German designs from North Africa. Working 20-hour days in the Hawaiian heat, sleeping in shifts beside their welding equipment, the Navy Construction Battalion men began creating something unprecedented. The resulting weapon, designated the CBH-1, Construction Battalion Hawaii 1, represented a quantum leap in flamethrower technology. Installation required 150 pounds of welding rod and 1,100 electrical connections, each one critical to the weapon's function. The conversion took 1,200 man-hours per tank, with 150 parts specially machined by CB metal workers. Each conversion cost between $20,000 and $25,000, equivalent to approximately $360,000 in modern currency. The technical specifications were revolutionary. The CBH-1 operated at 300 pounds per square inch pressure, triple that of previous designs. Maximum range extended to 150 yards with thickened fuel, nearly 3 times the distance of portable flamethrowers. The fuel mixture, a carefully calibrated blend of diesel fuel, gasoline, and napalm thickener developed by the 43rd Chemical Laboratory, would burn at 1,500 degrees Fahrenheit. The system could maintain continuous fire for up to 80 seconds, though Doctrine recommended bursts of 2 to 3 seconds to conserve fuel and maintain accuracy. Most critically, the flamethrower replaced the tank's main 75mm gun, allowing full turret traverse of 270 degrees and elevation from -10 to +35 degrees through the tank's existing fire control systems. The gunner could aim the flame weapon as accurately as a conventional cannon, using the same periscope and controls. This integration meant tank crews required minimal additional training to operate the new weapon effectively. The system incorporated multiple safety features designed to prevent catastrophic explosions that had plagued earlier flamethrower vehicles. The main fuel tanks held 290 gallons of thickened fuel with an additional 10 gallons of unthickened fuel for ignition. A separate pressure tank contained compressed nitrogen chosen over compressed air because nitrogen would not support combustion if the tank was struck by enemy fire. By January 1945, 8 M4A3 Shermans had been converted. They arrived at Schofield Barracks in standard Marine Corps olive drab with no special markings, no indication of their terrible purpose. The crews assigned to operate them had been carefully selected from experienced tank units with combat experience in the Pacific. These men understood armor tactics. They had fought in conventional tanks against Japanese anti-tank positions. They had experienced mechanical failures in combat and learned to adapt. They represented the kind of soldiers who could maintain calm while operating experimental weapons under fire. The 8 converted tanks were distributed to the 4th and 5th Tank Battalions, which would land on Iwo Jima in support of the main assault. Official designations included M4A3R5 and various other nomenclature including PO, A, CWS-H1, and CBMK-1. Some crews painted nicknames on their vehicles: Hellfire, Cork Crew, Blaze of Glory. Most remained unmarked, their purpose hidden until the moment of engagement. The tanks were held in reserve during the initial assault. Senior officers wanted to assess the tactical situation before committing these valuable and irreplaceable assets to combat. By February 20th, D+1, that assessment was complete. The tactical situation had become critical. The 21st Marine Regiment was pinned down attempting to cross Motoyama Airfield No. 1. 3 concrete pillboxes dominated the approaches, their interlocking machine gun fire creating a kill zone 200 yards wide. 2 rifle companies had already been decimated attempting frontal assaults. The regiment had suffered 35% casualties in less than 48 hours. The advance had stopped. Casualties were mounting. Officers were running out of options. The conventional weapons available to the Marines were not solving the problem. Something different was required. Lieutenant Colonel William Duplantis, commanding the 3rd Battalion, 21st Marines, made the decision that would change the battle's trajectory. He called for the flamethrower tanks, the 8 machines that had been held in reserve, the experimental weapons that some senior commanders still viewed with skepticism, were being committed to combat for the first time in the Pacific War. What would happen next would determine whether technological innovation could overcome the most formidable defensive positions the Japanese had constructed anywhere in the theater. At 14:20 hours on February 20, 1945, the first M4A3R3 flamethrower tank entered combat. Tank number 431, commanded by Staff Sergeant Robert Meza, a veteran of Saipan and Tinian, approached the Japanese positions from an oblique angle, using destroyed Japanese aircraft as cover. To Japanese observers watching from concealed positions, it appeared to be another standard Sherman tank attempting the same failed assault that had cost Marine lives all morning. The tank's approach was cautious. Meza understood that surprise would be their only advantage. Inside the five-man crew, each soldier prepared for action. Private First Class James Morrison, the driver, guided the 35-ton vehicle through volcanic ash that threatened to bog down the machine. Private Robert Chen manned the bow machine gun, watching for Japanese infantry attempting suicide charges. Corporal Anthony Vitelli checked the fuel pressure gauges, watching for the optimal reading of 300 psi. Corporal Thomas Carlson peered through his periscope, tracking the nearest pillbox through the battle haze. At 125 yards from the nearest pillbox, Meza gave the order that would mark the moment flamethrower tank warfare became reality. Gunner, flamethrower. Pillbox, fire. The CBH-1 erupted with a sound witnesses described as mechanical thunder. Stream of napalm-thickened fuel oil arced through the air, propelled by compressed nitrogen at 300 pounds per square inch. The burning liquid struck the pillbox aperture with devastating accuracy, splashing through the machine gun port and flowing inside like molten lava. The effect was instantaneous and complete. The concrete structure became an inferno. Temperatures inside the fortifications soared past 1,200 degrees Fahrenheit in seconds. The oxygen inside was consumed so rapidly that defenders suffocated before flames reached them. Those who survived the initial blast attempted to flee through rear exits, only to be cut down by Marine riflemen who had learned to position themselves for exactly this tactical moment. Staff Sergeant Meza traversed the turret 30 degrees and engaged the second pillbox. This time, the defenders were ready. A Japanese 47mm anti-tank gun, positioned in a concealed location, fired point blank. The shell struck the Sherman's frontal armor and ricocheted skyward. The tank shuddered but continued advancing. Carlson triggered another burst, maintaining fire for 15 seconds until black smoke billowed from every aperture of the fortification. The third pillbox required different tactics. Its position behind a rocky outcropping prevented direct engagement. Meza ordered Morrison to advance within 80 yards, dangerously close to Japanese infantry positions. As the tank crested a small rise, Japanese soldiers emerged from spider holes, rushing forward with satchel charges and magnetic mines. The tank's bowgunner opened fire with his .30 caliber machine gun, but several Japanese soldiers reached the vehicle's blind spot, the area directly behind the turret, where conventional Sherman tanks had no defensive capability. This was the moment when the CB engineers' design modifications proved their engineering worth. Unlike standard flamethrower tanks that could only fire forward, the CBH-1's full traverse capability allowed Carlson to swing the turret 180 degrees and fire directly behind the tank. The attacking infantry were consumed in seconds. With the third pillbox neutralized, Marines of the 21st Regiment advanced 400 yards in 2 hours, more progress than they had made in the previous 2 days. Word spread rapidly through the Marine communications network. The flamethrower tanks worked. More importantly, they survived where conventional tanks had failed. Within 6 hours, all 8 flamethrower tanks were in action across the front. Tank number 434, supporting the 23rd Marines near the East Boat Basin, destroyed 4 fortified positions in a single afternoon. Crews developed a technique called corkscrew and burn, approaching in a spiral pattern to avoid anti-tank fire while maintaining continuous flame suppression. The psychological effect on Japanese defenders was as devastating as the physical destruction. Japanese soldiers who had been trained to die at their posts began abandoning positions when they saw the flame tanks approaching, relinquishing fortifications rather than face the weapon they had never encountered in any previous Pacific battle. Tank number 437 pioneered breach and clear tactics with the 24th Marines. The flamethrower would first neutralize a position's defenders through sustained burning. Then Marine engineers would rush forward with satchel charges and demolition explosives to permanently destroy the fortification, collapsing tunnels and sealing cave entrances. This combination proved devastatingly effective against positions that had resisted days of conventional assault. In one afternoon, a single flame tank and engineer team destroyed 7 bunkers that had stopped an entire battalion's advance. Each destruction took between 20 and 30 minutes, a rate of tactical progress the Marines had never achieved against Kuribayashi's defensive system. The operational demands of sustained flamethrower operations revealed immediate logistical challenges. Tank number 431 exhausted its fuel supply after 80 seconds of continuous firing on the first day of combat. Refueling required withdrawing to designated areas where specialized fuel trucks waited, a process that consumed 2 hours minimum. During that time, Japanese defenders could reinforce threatened positions and reorganize their defenses. The tanks were powerful, but not inexhaustible. The fuel mixture itself required careful handling. Electrician's mate, second-class Kessler, one of the original designers who had accompanied the tanks to Iwo Jima to supervise maintenance, reported that the carefully calibrated blend of diesel fuel, gasoline, and napalm powder had to be used within 72 hours, or it would separate and clog the flame guns. This constraint meant maintaining fuel production at rates that required supply ships arriving from Pearl Harbor, with cargo specifically designated for flame tank operations. Fuel logistics alone consumed extraordinary resources. Fuel mixing stations operated 24 hours a day, combining diesel fuel, gasoline, and napalm powder in precise ratios. Personnel working these stations had been trained to recognize when the mixture was deteriorating and would be dangerous to use. Every gallon of flamethrower fuel represented a supply chain stretching back thousands of miles. 70,000 gallons of fuel mixture would be consumed in the first 7 days of flame tank combat, an average of 10,000 gallons per day. This consumption rate required establishing special fuel depots near the front lines, themselves vulnerable to Japanese artillery fire. The logistical effort to keep 8 tanks operational was equivalent to supplying an entire artillery battalion. Japanese defenders, watching the flamethrower tanks destroy their carefully prepared positions, quickly recognized the weapon's revolutionary nature. General Kuribayashi issued emergency orders the night after the first day of flame tank combat. The flame tanks were designated as priority targets. All available 47mm anti-tank guns were to concentrate fire on these vehicles. Special assault teams were organized, volunteers who would attack with explosive charges strapped to their bodies. Infantry units received instructions to target the flame tank's vision blocks with concentrated rifle fire, attempting to blind the crews. But the fundamental problem remained insurmountable. The flamethrower tanks looked identical to regular Shermans until they fired. Japanese gunners could not identify priority targets until the first burst of flame erupted. By then, even if they scored a hit, the tank's armor often protected the crew. Tank number 433 was damaged on February 22nd when Japanese artillery hit its left track, immobilizing it. The crew continued operating the flamethrower from a stationary position, while Marine infantrymen defended the disabled vehicle. Corporal Michael Rodriguez, the gunner on Tank 434, maintained fire for 45 seconds on Hill 382 on February 23rd, when a Japanese bunker had installed steel plates over its apertures, attempting to create a counter to the flame weapons. Rodriguez's observation that the steel plates glowed cherry red after sustained flame contact suggested they would warp and create gaps. He maintained fire far longer than Doctrine recommended, dangerously depleting fuel reserves. The steel plate buckled. The incendiary mixture poured through the gaps. Secondary explosions revealed tunnel entrances Japanese engineers had carefully concealed. By February 23rd, the same day Marines raised the American flag on Mount Suribachi, the flamethrower tanks had evolved from experimental weapons into the centerpiece of a combined arms system. Each flame tank operated with a dedicated support team. Conventional Shermans suppressed enemy anti-tank guns. Infantry provided close protection against suicide attackers. Engineers cleared obstacles and sealed destroyed positions. Ammunition carriers brought forward the 300-gallon fuel trailers that extended operational time. This integration represented a tactical revolution that would influence Marine Corps doctrine for decades. The adaptation of Japanese defensive tactics proceeded in parallel. Engineers installed steel plates over bunker apertures. Anti-tank guns were repositioned to engage flame tanks before they could deliver fire. Special tank killer squads were formed. Volunteers equipped with satchel charges who would attack disabled flame tanks. These adaptations achieved some successes. Tank number 438 was destroyed on March 11th when a Japanese soldier detonated himself against the vehicle's engine compartment, killing 3 of the 5 crew members and immobilizing the tank permanently. But such tactics were ultimately futile. For every flame tank damaged or destroyed, the technical team at Schofield Barracks had already begun manufacturing replacements. Damaged flame tanks that could be recovered were repaired and returned to action within 48 hours when spare parts arrived from Hawaii. By early March, the battle had shifted to Iwo Jima's northern plateau, a hellscape of sulfur pits, twisted ravines, and volcanic rock formations that made tank operations nearly impossible. General Kuribayashi had positioned his final defensive line here precisely because the terrain favored defenders. The area had been designated the meat grinder by Marines who faced 850 casualties taking a single hill. Tanks attempting to navigate the broken ground either lost tracks on sharp volcanic rock or bellied out on obstacles invisible beneath the ash. The flamethrower tanks adapted again. Unable to maneuver freely, they became mobile strongpoints positioned at key locations to support infantry advances. Marine engineers from the 5th Engineer Battalion worked through the night constructing ramps and clearing paths, often under sniper fire, allowing flame tanks to reach positions previously thought inaccessible. When direct assault proved impossible, tank crews fired indirectly, bouncing flame streams off rocks to reach around corners and into defilated positions. On March 8th, tank number 436 achieved what crews called the impossible shot. Supporting the 9th Marines' assault on Cushman's Pocket, a complex of caves and bunkers built into a near-vertical cliff face, the tank commander, Sergeant Daniel Foster, calculated that flame fired at maximum elevation might arc over the cliff edge and fall into Japanese positions from above. The physics were marginal. The CBH-1 flamethrower could elevate to 35 degrees, but reaching the target required a 40-degree angle. Foster ordered his driver to position the tank on a pile of rubble created by naval bombardment, tilting the entire vehicle backward. With the tank precariously balanced and enemy mortar rounds falling around them, Corporal Anthony Vitelli triggered the flamethrower. The molten napalm arced high into the air, hung for a moment at its apex, then cascaded down into the Japanese positions. The effect was devastating, not just physically, but psychologically. Japanese soldiers had believed their elevated positions were immune to flamethrower attack. That assumption died in the flames. Witnesses reported Japanese soldiers leaping from the cliffs rather than remaining in positions being attacked from above, choosing death by falling over death by fire. The tactical innovation of tilting the tank to achieve additional elevation represented exactly the kind of crew initiative that American military doctrine had trained soldiers to exercise. The crew had a mission: destroy the Japanese position. The textbook method was not available. They improvised and succeeded. By mid-March, the flamethrower tanks had evolved into the centerpiece of a combined arms system that broke every Japanese defensive anticipation. The tanks appeared at decisive points to neutralize specific strong points blocking infantry advance. They operated with dedicated infantry support, armor protection, and engineering expertise. They consumed vast quantities of fuel brought forward through supply chains that extended back to Pearl Harbor. They required maintenance that consumed scarce parts and technical expertise. But every day they operated, the advance continued. Every position they neutralized reduced American casualties. Every Japanese position destroyed was one fewer location where Marines would die attempting assault. Tank number 431, the first flamethrower tank to see combat, was repaired after being disabled on Hill 382 and continued operations throughout the campaign. Its armor bore the scars of combat, welded patches where shell fragments had penetrated, dents from dozens of hits that had failed to penetrate, scorch marks from near misses. The crew learned the weapon's capabilities through experience. They learned how long to sustain fire to ensure a position was completely destroyed. They learned how to position the tank to maximize coverage. They learned how to coordinate with infantry to exploit the psychological shock of flamethrower attacks. By the time the battle reached its final phase, the 8 flamethrower tanks had become so effective that Japanese defensive positions began collapsing not from direct flame attacks, but from the knowledge that flame tanks would eventually arrive. The statistics from the first week of combat told a remarkable story. In sectors where flamethrower tanks operated, Marine casualties dropped by approximately 40% compared to unsupported attacks on equivalent positions. Japanese fortifications that had resisted days of conventional assault fell within hours of flame tank engagement. The 8 tanks had consumed 70,000 gallons of fuel mixture in 7 days, destroying an estimated 300 fortified positions. Daily consumption averaged 10,000 gallons, a logistical challenge that required establishing special fuel depots near the front lines and bringing supplies directly from Navy ships offshore. On March 21, 1945, D+30, all operational flamethrower tanks, 6 of the original 8 with 2 undergoing repair, concentrated for a coordinated assault on the gorge, Kuribayashi's final stronghold. This twisted maze of ravines and caves, nicknamed the Bloody Gorge by Marines, represented the ultimate test of American tactical innovation against Japanese defensive determination. The terrain here was the most challenging of the entire campaign. Narrow passages that prevented tank maneuver, vertical cliff faces that provided defensive positions overlooking approaches, underground caverns that extended below ground level, creating firing positions that conventional weapons could not suppress. Here, in an area less than 700 yards square, the remaining 3,000 Japanese defenders prepared to make their last stand. The assault began at 1,000 hours, with the tanks advancing in a crescent formation, creating overlapping fields of flame that left no dead space for Japanese defenders to exploit. Marine infantry followed in their wake, throwing white phosphorus grenades into cave entrances to mark targets for the flame tanks. Engineers with demolition charges sealed positions after the flamethrowers had cleared them, collapsing tunnel entrances and preventing Japanese soldiers from reoccupying destroyed positions. The Japanese resistance was fanatical but increasingly futile. Suicide squads charged from hidden spider holes only to be incinerated before reaching their targets. Anti-tank guns fired point blank, their crews maintaining fire even as flames engulfed their positions. In one extraordinary incident reported by witnesses, a Japanese officer emerged from a bunker carrying a samurai sword, charging directly at tank number 434 in what appeared to be a final act of defiance. The tank's bowgunner held his fire, perhaps from shock or respect. Marine riflemen cut down the officer just yards from the vehicle. His sword was later recovered and sent to Marine Corps headquarters as a symbol of the enemy's desperate courage in the face of unprecedented weaponry. By sunset on March 21st, the gorge had been penetrated. Over 800 Japanese defenders lay dead, many burned beyond recognition. The flamethrower tanks had consumed 8,000 gallons of fuel mixture in a single day, a record for the campaign. Marine casualties, while still significant at 92 killed and 257 wounded, were a fraction of what conventional assault would have cost. Every estimate suggested that capturing the gorge through infantry assault alone would have required at least 5 days of fighting and casualties exceeding 1,000 men. The flamethrower tanks had accomplished the objective in 1 day, while reducing American losses by an estimated 90%. On March 26, 1945, Iwo Jima was declared secure. The battle had lasted 36 days instead of the 5 days American planners had projected. American casualties totaled 26,038, including 6,821 killed. Numbers that shocked the American public and military leadership. Japanese losses were nearly total. Of approximately 21,000 defenders, only 216 survived as prisoners. The rest died fighting or, in increasing numbers as the battle progressed, chose suicide rather than face capture or burning. Post-action analysis by the Marine Corps credited the flamethrower tanks with reducing American casualties by an estimated 5,000 men. They had destroyed over 1,000 fortified positions across the campaign. Statistical analysis revealed the true impact. Over 30% of Japanese casualties on Iwo Jima were caused by flame weapons, both tank-mounted and portable. In sectors where flame tanks operated, the rate of advance increased by 300% compared to unsupported attacks. Japanese prisoners, a rarity in Pacific battles, numbered 216, more than the combined total from Tarawa, Saipan, and Peleliu. Many specifically cited fear of incineration as their reason for surrendering, a phenomenon never before observed in Japanese military doctrine. The tactical implications extended far beyond Iwo Jima. The Marine Corps immediately requisitioned 54 additional flamethrower tanks for future operations. Colonel Unmarked's team at Schofield Barracks went into accelerated production. Working with WWII priority, the same classification assigned to the B-29 bomber and the Manhattan Project, engineers developed the improved CBH-2 model with increased range and reliability. By June 1945, 70 new flame tanks were ready for Operation Downfall, the planned invasion of Japan. The Army, observing Marine success at Iwo Jima, accelerated its own flamethrower tank program. The entire 713th Tank Battalion was converted to flame tanks for the Okinawa campaign. During the Battle of Okinawa in April and June 1945, Army flame tanks would consume 200,000 gallons of fuel mixture, proving equally effective against Japanese cave complexes in the southern part of the island. The weapon that had been a last-minute improvisation became standard equipment for Pacific operations. Production statistics reflected the commitment to this new tactical capability. Colonel Unmarked's flame tank group ultimately produced 354 flame tanks by war's end. The Navy construction battalions at Schofield Barracks manufactured 226,343 gallons of flamethrower fuel. The napalm mixing plant they constructed could produce 1,000 gallons per day, running continuously to meet the demands of Marine and Army operations throughout the Pacific. This industrial capability, replicated across supply bases from Pearl Harbor to forward areas in the Pacific, meant American forces could systematically apply flame weapons to break through Japanese defensive positions. The operational integration of flamethrower tanks in subsequent campaigns revealed lessons learned from Iwo Jima. By the time American forces landed on Okinawa, doctrine for flame tank employment had evolved significantly. Crews understood optimal ranges and sustained fire durations. Infantry units had learned to coordinate with flame tanks to maximize the psychological shock effect. Engineers had developed techniques for sealing destroyed positions permanently. Tank commanders had learned to position flame tanks to create overlapping coverage that prevented defenders from reoccupying adjacent positions. These doctrinal refinements, tested under fire at Iwo Jima, were codified in Marine Corps field manuals and distributed throughout the Pacific theater. The psychological impact on Japanese defenders became increasingly documented through prisoner interrogations and captured documents. Soldiers who had been taught that death in battle guaranteed spiritual transcendence found themselves paralyzed by the fear of incineration. The dishonor of fleeing combat positions seemed preferable to death by burning in underground fortresses. Lieutenant Yamada, who reportedly witnessed the first flamethrower tank attack on February 20th, survived the battle as one of the 216 prisoners. In post-war testimony to American intelligence officers, he reflected on the psychological transformation. We had prepared for every form of death: bullets, shells, bayonets, starvation. We had not prepared for burning petroleum that sought us out in our deepest bunkers. The flame tanks broke our spirit in ways no conventional weapon could. They turned our greatest strength, our underground fortifications, into death traps. Former Japanese defenders, captured after observing flame tank operations, provided consistent testimony about the weapon's impact on morale. Traditional Japanese military doctrine had emphasized the spiritual transcendence of death in battle, but the methodology had always assumed conventional combat. Enemy soldiers with bayonets, artillery explosions, machine gun fire. These represented honorable forms of combat death. But burning petroleum that could not be escaped, that filled underground shelters, that consumed oxygen faster than soldiers could breathe, this violated every assumption about acceptable death in combat. Japanese officers reported receiving orders from panicked defenders requesting permission to abandon positions once flame tanks appeared on the battlefield. Senior commanders struggled to understand how troops trained for decades to die at their posts could suddenly abandon fortifications when facing this specific weapon. The military implications reached beyond the Pacific theater. The United States Army, analyzing the success of flame tanks at Iwo Jima, fundamentally restructured assault doctrine around combined arms tactics, integrating armor, infantry, and engineers. The concept of specialized armor platforms designed for specific battlefield problems became standard military thinking. Future weapons development would prioritize adaptability and innovation over pure firepower. The technology itself continued evolving. The M4A3R3 Sherman flamethrower tanks served in Korea, where they proved equally effective against Chinese bunker complexes during the battles for the Punch Bowl and Heartbreak Ridge. Marine flame tanks destroyed over 300 Chinese positions during the Korean War, though with less dramatic effect due to better Chinese awareness of the weapon's capabilities and fewer fortified positions as elaborate as those at Iwo Jima. The mechanical evolution of the flamethrower tank continued through subsequent decades. Improved models incorporated better fuel systems, more efficient burner designs, and enhanced crew protection. The M132 armored flamethrower, based on the M113 armored personnel carrier, represented the final evolution of flamethrower tank design in American service. These vehicles served from the Korean War through Vietnam and into the early 1970s. The last American flame tank wasn't officially retired until 1978, ending a weapons lineage that began with 8 hastily modified Shermans in a secret warehouse in Hawaii. By then, thermobaric weapons and precision-guided munitions had replaced flamethrowers as the primary means of defeating fortified positions. International law eventually restricted flamethrower use with Protocol 3 of the Convention on certain conventional weapons, limiting incendiary weapons used to specific military circumstances. The weapon that had been decisive at Iwo Jima became controversial as public opinion shifted against weapons deemed excessively destructive. Yet military historians note the strategic irony. The flamethrower tanks, for all the ethical questions surrounding their employment, had shortened one of the Pacific War's bloodiest battles and potentially saved thousands of American lives that conventional assault would have claimed. The calculus of war, where technological capability is measured against casualty reduction, suggested that the flamethrower tank represented a net benefit in terms of human life saved. The industrial achievement supporting these weapons cannot be overstated. The United States produced 49,234 Sherman tanks during World War II. Only 354 were converted to flamethrower configuration. Yet these few hundred vehicles had impact far exceeding their numbers. At Iwo Jima, 8 tanks had changed the course of a battle that might have lasted months and cost tens of thousands more casualties. The production cost, roughly $200,000 per converted tank in 1945 dollars, seems trivial compared to the lives saved. Military analysts calculated that each flame tank at Iwo Jima potentially preserved 625 American casualties based on comparative casualty rates in flame-supported versus unsupported attacks. In the cold calculus of military cost-benefit analysis, the investment in technological innovation had paid enormous dividends in American lives preserved. The Navy Construction Battalion personnel and Army chemical officers who designed and maintained the flame tanks received little public recognition. Electricians Mate Kessler and other technical personnel returned to civilian life after the war, their names forgotten except in obscure technical reports and naval archives. Colonel Unmarked continued developing chemical weapons systems until retirement, his contribution to victory known only to a few military historians and Pentagon officials. The tank crews faced different challenges. Many struggled with what would later be recognized as post-traumatic stress disorder. The memory of combat involving these weapons created psychological effects distinct from conventional tank warfare. Staff Sergeant Meza never spoke publicly of his service until shortly before his death in 1993, telling his grandson, "We did what we had to do." Nobody should be proud of burning men alive, but those tanks saved a lot of Marine lives. That's what I try to remember. Veterans of the flame tanks formed their own informal support network after the war. They met annually in Hawaii, returning to Schofield Barracks where their weapons had been created. These reunions, unreported by media, allowed men to share experiences that were too complex for civilian understanding. The last reunion was held in 2010, attended by only 4 surviving crew members. As the group aged and passed away, the direct testimony of flame tank veterans became increasingly rare. The Japanese military archives, open to researchers in the 1980s, provide the enemy perspective on facing flame tank assault. Report after report describes the paralysis of watching liquid fire approach, knowing that concrete and steel offered no protection. Orders to hold positions to the death became meaningless when death came as flowing fire that sought out every hiding place. One captured Japanese intelligence report noted, "The flame tanks negated every advantage of our defensive positions. Height meant nothing when fire could arc over obstacles. Depth meant nothing when flame flowed like water into our tunnels. Concrete and steel that could withstand tons of explosives were useless against liquid fire." General Kuribayashi's final message, transmitted just before his death in late March 1945, contained a prescient observation about the nature of modern warfare. The Americans have not just defeated us with superior numbers or firepower. They have defeated us with superior imagination, turning our greatest strength, our underground fortifications, into death traps. Future wars will belong to nations that can imagine new forms of warfare, not those who perfect old ones. His prediction proved accurate. The revolution in military affairs that began with 8 flame tanks at Iwo Jima continued through guided missiles, precision weapons, and cyber warfare. The principle remained constant. Technological innovation defeats traditional tactics. Imagination triumphs over convention. The transformation from conventional to flame warfare at Iwo Jima took just days, but changed combat doctrine forever. Marines who had been trained for traditional assault tactics learned to coordinate with flame tanks using their shock effect to break defensive lines, thought impregnable. This integration happened not through formal training, but through battlefield innovation and adaptation under fire that exemplified American military flexibility. Senior commanders observed what worked and modified their tactics accordingly. Junior leaders saw opportunities and exploited them without waiting for higher headquarters approval. This tactical culture, developed over years of Pacific Island campaigns, reached its culmination at Iwo Jima. The Battle of Iwo Jima was ultimately won not by courage alone, though courage existed in abundance on both sides, but by the marriage of American industrial capability and battlefield innovation. The flamethrower tanks represented the convergence of technology, tactics, and determination that would define American military superiority for generations to come. 8 modified Shermans had changed the nature of warfare, demonstrating that victory in modern conflict belonged to nations capable of wielding industrial might as a tactical weapon. Japanese defenders had fought with unprecedented bravery, following orders to resist to the death. They had built the most formidable defensive position in the Pacific War, a subterranean fortress that conventional weapons could not reduce. But they had not anticipated incendiary weapons that poured like molten rain, seeking out every cave and bunker, turning their underground sanctuary into something they had never imagined facing. Their defeat was not a failure of courage, but a collision with superior technology and innovation. The numbers tell the final story with brutal clarity. 8 flamethrower tanks, 360,000 gallons of fuel mixture consumed, over 1,000 fortified positions destroyed, an estimated 5,000 American casualties prevented, over 6,000 Japanese soldiers killed by flame weapons, 36 days of combat that might have stretched to months without flame weapons. The mathematics of modern warfare, where technological advantage translates directly to lives saved and battles won. Today, the last surviving flamethrower tank from Iwo Jima, tank number 434, sits in the National Museum of the Marine Corps in Quantico, Virginia. The tank bears the scars of its service, welding marks where armor was patched, dents from shell impacts, scratches from volcanic rock. A small plaque notes its specifications and battle history. Visitors often pause longer at this exhibit than others, disturbed by the weapon's purpose but recognizing its historical significance. Schoolchildren ask why anyone would create such a weapon. Veterans who understand its history stand silently, some saluting, others simply staring in remembrance. For them, the tank represents not glorification of war, but recognition of war's terrible necessities. The revolution in military thinking that began at Iwo Jima continues to influence doctrine worldwide. Modern armies emphasize the importance of specialized armor for specific battlefield problems. Tanks designed to carry bridge-laying equipment, mine-clearing systems, infantry support weapons, and specialized sensors represent the evolutionary line extending directly from the flamethrower tank concept. The principle established at Iwo Jima that armor platforms can be adapted to solve specific, tactical problems has become fundamental to modern combined arms doctrine. The flamethrower tank itself is obsolete, but the thinking that created it remains relevant. The Battle of Iwo Jima stands as one of the Pacific War's most brutal and most decisive engagements. The flamethrower tanks represented only one factor in American victory. Courage, sacrifice, and determination by both American and Japanese forces were equally important. Naval gunfire support, aerial bombardment, infantry tactics, and logistical support all contributed to the outcome. But the flamethrower tanks represented something distinct. They represented the capacity of American industry and innovation to create new solutions to unprecedented problems. They represented the willingness of military leaders to commit resources to experimental weapons. They represented the ability of crews to master new technology under the most demanding combat conditions. In the end, the 8 flamethrower tanks that fought at Iwo Jima became instruments of a tactical revolution that shortened one of the Pacific War's bloodiest battles. The men who designed them, the crews who operated them, and the Japanese defenders who faced them were all part of a transformation that would define modern warfare. The volcanic island of Iwo Jima, now returned to Japan and officially named Iwo To, bears few visible scars of the battle that once raged across its surface. Nature has reclaimed the battlefield, covering shell craters with vegetation, filling trenches with volcanic soil. But beneath the surface, sealed caves and collapsed tunnels still hold the remains of soldiers who died in combat. Their sacrifice is remembered by ever fewer living witnesses as the decades pass. The flamethrower tanks of Iwo Jima stand as testament to what becomes possible when military necessity drives technological innovation. 8 modified Shermans had changed the nature of warfare, demonstrated that breakthrough in military capability could come from bold experimentation, and proved that the side with superior imagination could overcome even the most formidable defensive positions. The age of the warrior had been supplemented by the age of technological warfare. The principles established in 1945 continue to shape military thinking in the 21st century. Industrial capacity, technological innovation, and tactical flexibility remain the foundation of modern military superiority.